Okay, welcome to 5.7. This is the second to last section in this chapter. 5.7 is division of polynomials. We actually do two sections about division, this one and the one that follows. They're just two different methods. This is a video you should expect to watch more than once. This is a process, this long division of polynomials that we're going to do mostly in this section, that you need to take some time and just practice. The more you practice it, the better things will be, I promise. It just takes a little bit of patience. So know that going in and just be willing to redo them and try them, okay? So we're going to start with division by a monomial. So if a, b, and c are polynomials such that c is not equal to 0, if I have a plus b over c, then it's the same as a over b plus b over c. It's basically like I can split the fractions. If I have terms in the numerator being added and subtracted over a single denominator, I can break them up. This is division by a monomial because the denominator doesn't have any operations other than multiplication in it. Okay, it's a single term in the denominator. So for example, this is what I have here. So I have 5a cubed minus 10a squared plus 20 all divided by 5a. 5a is a monomial, so what I can do is I can think about this as 5a cubed over 5a minus 10a squared over 5a plus 20 over 5a. I can think about them each as individual fractions, and then I can simplify each one. So in the first fraction, the 5's cancel, the a on the bottom cancels, and I'm left with a squared on top. In the second fraction, 5 goes into 10 twice. A squared minus a just leaves just 1a. And then in the last one, 5 goes into 24 times, and there's an a left over on the bottom. So I'm going to get a squared plus 2a plus 4 over a. It's not pretty, but it's the answer. Like, you don't have to love the answer for it to be correct. This one is written differently, but it's the same exact thing. So I can think of it when I divide by, it's just the same as writing it as a fraction. So I'm going to write these each as individual fractions. 12yz cubed divided by negative 6y squared z minus 15yz cubed z squared divided by negative 6y squared z, and then plus 6y squared z divided by negative 6y squared z. All right, so now I'm going to simplify. Negative 6 goes into 12, that's negative 2. Y squared and y squared cancel. Z and z cubed and z on the bottom become z squared. So that becomes negative 2z squared. Negative 6 and 15, well, 6 doesn't go cleanly into 15, so it simplifies. They're both divisible by 3. Negative and negative is positive, so I get positive 5 over 2. Y on the top, y on the bottom is true, it leaves 1 y in the bottom. And then z on the bottom goes into z squared once, so that leaves a z on top. And then negative 6 or positive 6yz is y squared z minus 6y squared z divided by negative 6. Let me say that whole thing again. 6y squared z divided by negative 6y squared z is just, they all cancel. And the negative's left, so it's a negative 1. When they all cancel like that, there is a placeholder left when you're finished. That term just doesn't drop away. That negative 1 or plus 1 has to be there, or else the answer is incorrect. The other process we need to learn in here is long division. So I'm going to step through this pretty slowly initially, and you need to practice this. So we're going to set this up just like we would long division, like when you're a little kid in 4th grade. So x minus 3 is on the outside. Inside the division symbol goes 2x squared minus x plus 3. And here's what I'm going to do. I'm going to think, how do I turn x, that front x in front of the x minus 3, into 2x squared? What can I multiply it by? Well, I can multiply it by 2. That would get me the 2 for the x. And x, to turn x into an x squared, I need one more x, because x squared is just 2 x's, right? So if I multiply by 2x, I multiply x squared, or x by 2x, I would get 2x squared. So I'm going to do that. That goes right there, 2x squared. But I'm also going to multiply that to the negative 3. So 2 times negative 3x, or 2x times negative 3 is negative 6x. Now here is the trick to this. What I'm going to do at this point is I'm going to pause, put these in parentheses. Ugh. This didn't draw properly. Put them in parentheses and subtract this. This is the step that if this goes wrong, this is the problem. So it becomes minus 2x squared and plus 6x. And then I'm going to do that subtraction. So the first term cancels. Then I have minus x plus 6x. It's going to be positive 5x. Bring down the 3. Now I'm going to do the whole process again. So I'm going to start fresh and I'm going to think to myself, okay, how do I turn this x in front of x minus 3 into 5x? Well, I multiply by 5. So I'm going to put plus 5 here. And then I'm going to multiply. It's going to go here. So it's going to be 5x. And then 5 times negative 3 minus 15. Okay. And then remember from last time, put it in parentheses and subtract. It's always the step here. So 5x minus 5x is nothing. This negative distributes, that becomes a positive. 5 plus 15 is 20. At this point, that's the remainder. So we're done. So what the answer here is, the answer is 2x plus 5. And then the remainder gets put over what you've been dividing by in a fraction. Plus 20 over x minus 3. Okay, if you need to go through that again, go ahead and do that. Let's do the second one. So I'm going to do the exact same thing. X plus 2 on the outside. 3x squared plus 2x minus 5 on the inside. Okay, so first step is to say, how do I turn this x into a 3x squared? Well, I need an x. X times x means x squared. And I need a 3. And then I'm going to multiply. So 3x squared. 3x times 2 is plus 6x. Okay, then I'm going to put it in parentheses and subtract. So that becomes minus 3x and minus 6x. So these guys cancel. The 2x minus 6x makes negative 4x. Bring down the negative 5. Now I'm going to do the same process, right? I'm going to turn x into a negative 4x. Well, it means I need to multiply by negative 4. X with a y. So distribute that negative 4. X times negative 4 is negative 4x. Negative 4 times 2 is negative 8. Put it in parentheses and subtract. So that becomes a plus. Those cancel. Negative 5 plus 8 is just 3. So then the answer to this one is 3x minus 4 plus 3 over x plus 2. Okay, let's do some more. When we do this, there is one trick you have to pay attention to. And the trick is this. the polynomial being divided, this first one, and the polynomial doing the division have to be in standard form. What this means is they have to have every exponent, every variable accounted for. So this guy has a w cubed, a w squared, and a 3. What it's missing is a plain w. So if something is missing, you need to fill it in using a 0. So what happens is this. I'm going to rewrite this as division. I'm going to do 3w minus 1 on the outside. On the inside, I'm going to do 3w cubed plus 26w squared plus 0 w's minus 3. I cannot have a missing spot, okay? But then from here, the process is the same. So I'm going to turn 3w into 3w cubed. So I just need 2 more w's. Multiply by w squared. Distribute. So that's going to be 3w squared, or 3w cubed, pardon me, minus w squared. Put it in parentheses and subtract. That becomes a plus. So these guys cancel. This becomes 27w squared plus 0w. And this is why, if you were missing a place value, the division process is not going to work. So now I have to think, how do I turn 3w into 27w squared? Well, 3 times 9 is 27, and w times w is w squared. And distribute. Process is the same. I'm going to get 27w squared. Oops, it helps if I break the 7. And then 9w times negative 1 is minus 9w. All right, just like before, put it in parentheses, subtract. Here comes subtraction, that comes plus. So 27's cancel. It becomes 9w. Bring down the 3, negative 3. So now how do I turn 3w into 9w? Multiply by 3. So I get 9w. 3 times negative 1 is negative 3. Put it in parentheses and subtract. That becomes subtract. That comes plus. And actually, in this case, both of them cancel. It gets me a 0, which means there's no remainder. So my answer is just w squared plus 9w plus 5. Okay, so let's try the next one. Erase that. Look at the next one and find what's missing. What's missing in the numerator? I have cubed, a regular x, and a 10. So I'm actually missing squared. 3x plus 2 on the outside. On the inside, I need to write that a little lower. Space. I have 9x cubed plus 0x squared. I have to hold that place. Plus 11x plus 10. So same process. Turn 3x into 9x cubed. I need 3x squared. Distribute. So I get 9x cubed plus 6x squared. Put it in parentheses and subtract. This is subtract. This is subtract. So those guys cancel, and I get 6x squared. Bring down the 11x plus 11x. So now I'm going to turn 3x into 6x squared. I'm going to do, let's see, I need an x and a 2, right? So multiply by 2x. So 3x times 2x is 6x squared. 2x times 2 is plus 4x. Subtract. Those guys cancel. That guy becomes a minus, so I get 7x. Right? Nope, I don't. Look at my signs. Nope, that's right. Okay. So minus, something's off somewhere. I could draw my sign for 8 plus. I don't know. Okay. Well, it's okay. Doesn't really matter. So minus, it does matter because I can't make a 7. Plus 6x. Oh, I know what happened. This became a minus. That should have been negative. Ah, I knew there was a problem. See, and it happens to me too, where something goes slightly wrong. So it should have been minus 2x. This should have been a negative 6 to start. This should have been a positive. It should have been negative, becomes positive. Okay. Whew. So let me make that all a little clearer. So originally it should have been minus 2x gets me minus 4x. When I multiply by the negative, this becomes positive. Okay. I knew there was a problem with a sign somewhere around here. I can't get the eraser. Problem. All right, so this becomes 15x. And sometimes what you'll see is like, can't turn a 3 into a 7. I might have done something wrong and I knew that. That's how I knew to check. So 15x, I want to make 3x 15x, and we multiply by plus 5. That's going to make this 15x. 5 times 2 is 10. Put them in parentheses and subtract. I end up with 0. So my final answer is 3x squared minus 2x plus 5. All right, these are more examples of the same. Your job is to fill in the zeros. Okay, you cannot just leave empty spaces, right? So try them. I'm going to do one of the ones on this page and I'll leave the other one for you to try. Keep in mind, they have to be in standard form first. This is not even near standard form, nor is the bottom. So on the top, I'm going to divide into, I need y squared. I don't have any y's, so I need plus 0y plus 1. On the inside, y to the 4th plus 0y cubed, and I don't have any y squareds, plus 2y minus 5. Lots going on there, but this is going to be okay, so watch. So I want to turn y to the squared into y to the 4th. I just need squared for that. I'm going to distribute to all 3. So y to the 4th, 0 times y squared is just 0 anything. And then y squared times 1 is just y squared, plus, plus. Put them in some parentheses and subtract. This gets to be subtract, that and that. So cancels. Doesn't turn into anything, this 0y cubed. Okay? So this becomes a 0 here, plus 0y cubed, because I'm going to skip this space altogether. Those go away. And then I have negative y squared here. So now I'm going to bring down everything else because I need 3 terms at a time. So I brought down 1. I'm going to bring down the next 2. If I had had a 0 here, I could have brought down just 1. But I need as many terms to multiply into as I have here in my denominator. Okay, so y squared to negative y squared, I just need a negative 1. So that becomes negative y squared minus 0 y's minus 1. Put it in parentheses and subtract. Those cancel. That just becomes 2y. And that becomes minus 4. So at this point, I can't go any further because I can't turn a y squared into a 2y. It's going the wrong direction. So what my answer is, y squared, this is minus 1 plus 2y minus 4 over y squared plus 1. That's it. You try the next one. I will tell you the answer is x minus 1 plus negative 2x plus 6 over x squared plus 2. Fill in the zeros, put it in standard form, try it. Okay, bring it into the discussion if you're not sure. Now, this slide, all you're going to decide is if you have to do long division or you can divide by just the monomial. So do we need long division or not? Well, if you look at A, yeah, I need long division because here, this is way more than a monomial, right? There's lots more going on there. But for B, I don't need it because all I have is a single term here in the denominator. For C, the answer is also no, I don't need long division because again, single term. And then for D, yes, long division. Okay, so if you need to watch this video again, please do. If you need help, reach out. Please ask your questions and we'll see you in the next one.